Standard deviation is a measure of how spread out the values are in a data set relative to mean. This is a normal distribution. That's the mean. And each of these lines represents a standard deviation. Within one standard deviation from mean, we'll find 68.2% of the data. And within two, there will be 95.4%. Outliers are found 2 standard deviations away from the mean or further, and we'll find 4.4% of the results there.
This is a standard deviation equation. This represents the sum of. X represents the data that we have collected. N represents the number of items in the data. Sum of x over n represents the mean because you add them all together and divide them by how many there are to find the mean.
So first of all, we're going to have to get this first part of the equation. So these are x all lined up here, and we're going to have to get x squared to start off with. So x squared, 5 squared is 25, 16 squared is 256, 14 squared is 196, 20 squared is 400, and 3 squared is 9. So after we've got that, we're going to have to add them all up, and when you get the sum of x squared, you get 886. Then, as you can see, we're going to have to divide this by 5 because that's the number of that is there. So over n is 134.56. No, that's wrong. It's 177.2. So that's the first part of the equation there. So we're going to write that over here, 177.2. And then now we're going to have to do the second part of the equation, which is sum of x over n. So the sum of x, as we found out earlier, is 58, and then over n, which this also will give us the mean, is 11.6 because it's over 5. So this is sum of x, and then to get the mean, it's 11.6. So then after this, we're going to have to square this one. So when we square that, it will give us sum of x over n all squared equals 134.56. This is our second number, so what we're going to have to do is we're just going to have to minus this by this. So to get the bottom part, to get the equation before it's square rooted, is 177.2 minus 134.56. This gives us 42.64. Then all we have to simply do is square root this number, which the square root of 42.64 gives us 6.53. So our standard deviation equals 6.53.
So in comparison to Matt's example before, we'll be using group data this time. Now you could use Matt's method on how to do it, but for each one you'd have to do it multiple times. So you'd have to do 1 squared, and then you'd have to do 2 squared, then you have to add that 7 times. So it'd be 2 squared, 2 plus 2 squared plus 2 squared plus 2 squared 7 times, and then you do the same for 3, 4, 5. But this is a much easier method by using frequency, so the frequency of the result. So for example, getting a 2 7 times. So we'll be using frequency in the equation. So starting at the first bit, which is the sum of frequency times x squared. So you have to square the x values and then times them by frequency. So we've got 1, 28, 54, 64, 75, and 144. Now, those added all together is 366. Now, to use it in the equation, we have to divide it by the sum of the frequency instead of n, which is 25. So, fx squared, the sum of fx squared, over the sum of the frequencies is 366 over 25, which equals 14.64. Now it's the same in this one, except for obviously we don't have a squared here, so we're just timesing the two numbers of x and the frequency together. So that's 1, 14, 18, 16, 15, and 24. And adding all those together, 8. Now, in the equation you can see that it's the sum of fx over the sum of f all squared. So we have to do sum of fx over the sum of f all squared, which equals 88 over 25 squared, which gives us a grand total of 12.3904. Now we need to complete our standard deviation equation. So SD equals our number that we've got before, which is, so we need to square root it, 14.64 minus 12.3904, which if you do the working out inside the square root is equal to the square root of 2.2496, which overall equals 1.4.